Okay, so now we went and hit the record button. Obviously, you guys have just got your lab left, and then you've got your wonderful final. Remember, guys, with the final, think fully through the questions. Some folks are going to really just jump ahead and like, I got it. Like, they're meant to be relatively decent sized essays. And then when it comes to on my end for grading it, breaking your thoughts into individual paragraphs makes it a lot easier for me to go through it than if it's just this angry block of text that is kind of this weird meandering with no real consistent movement in one direction. It just becomes more daunting for me. And then, hey, things, no, girl, you never get enough attention. Never get enough attention. Seeing as I had reset our wonderful Wi-Fi, and that's why it took me a few moments to get this thing up and running, because MetroNet is not, or sorry, Windstream is not that great. That's why we're thinking about MetroNet. Yeah, as you can tell, her life is pain. She really enjoys getting her ears scratched. But if I even so much as dare try and pet her stomach, its claws freaking out. And then same thing, she'll just hit a point where she's had enough. So, like for example, the neurological system. If we're going to try to adapt it to training, what are the two major mechanisms of how we can just adapt the nervous system in general? What are the two major mechanisms there? And this is for anybody, not just picking on Tori anymore.
Are you talking like sympathetic and parasympathetic?
Okay, so now you're taking it the direction of the autonomic nervous system, which obviously does have an importance, but we got to think about what are the mechanisms for changing the nervous system. So if we're trying to send a signal faster, what can we do to increase that?
Hey, out.
Hmm? What can we do to send that signal faster? Go for it, Bree, you're unmuted.
Oh, I just realized that. Releasing acetylcholine? Question mark.
That's okay. Now, remember, that's the major neurotransmitter for muscular contraction, and it's the other major neurotransmitter for actually our parasympathetic nervous system. So that's what it releases to help slow down our heart rate through vagal tone. But we can increase the diameter of our axons, which are going to send the signal faster, or we can, or we can myelinate the dendrites and the axons. So that way we can use saltatory conduction and the signal can go faster. So that's how we literally enhance our speed of those contractions, information coming through. Now, the other side is when we talk about connections in the brain. So we literally are going to see an increase in connections in the areas that we're utilizing more, which in turn obviously means we're able to send a signal faster and be able to do it in a more controlled and effectively more efficient manner. So when we're talking about the adaptations of the nervous system, obviously that shows anything from increasing force production to that inter and intramuscular coordination. And that's all just occurring thanks to the adaptations of the inputs and then the frequency of practice, along with giving enough time to recover. So we need to make sure we dive down into the mechanism. Now, Courtney brought up a good point, which is the autonomic nervous system, sympathetic tone and parasympathetic tone. How we talked about how there's an optimal amount of that for any individual to have in specifically what they're trying to do. So if you're looking at trying to be the best archer you can, you need to make sure that you are effectively as relaxed as possible so we don't have any excess sympathetic tone. So we're going to have much more stable hands, and that is the cat's claws in my back. This shirt is too thin for that nonsense today, Tinks. Too thin for that. So yeah, come on up here so they can see that you're a jerk. Okay, I'll pet your ears. Oh, wow, that was invigorating. Floor. sorry guys, the joys of working from home. And then when we're looking at our autonomic nervous system, specifically sympathetic tone, we probably want to be as far into that when we're doing things that are relatively simple technically, but need to be massive force outputs, power outputs. So this would literally be doing something like, sorry, she was obviously trying to push up against my arm and she lost her footing and just fell on the ground. She is our least athletic cat. Mind you, we only have two, so it's not like there's a big ranking system. But with the autonomic nervous system and the sympathetic tone, that's when we're talking about doing things like powerlifting, specifically when we're talking about deadlifting or squatting or bench pressing. It's not that technical of a movement, but you need to be able to tap into all of those muscle fibers so you can get the greatest, most powerful contraction. And then you think about roles in a sport. If your goal is to be a defensive lineman, it's a relatively simple number of skills to actually be it. There are some tactics involved, but there's a lot of just straight up aggression that's probably going to help you a lot in those given roles. Whereas, Snickers, I know, you never get any attention. You never get any attention. So, I know. Where you look at something like a quarterback or you look at a role like a kicker, they need to have not as much of the sympathetic tone because they still need the very high level motor control of their bodies so that they're going to be able to do those complex movements correctly. Welcome to my life. Yes, I know, Kitty. I know. Your life is pain. Your life is pain. So think through everything that's far reaching. So not just would we want to talk about the autonomic nervous system if we're trying to optimize an athlete, we're going to still talk about the somatic system, so our ability to literally contract those muscles specific to our goals. We're going to want to increase our afferent side, so literally our ability to perceive information, our ability of our thalamus to interact, or essentially to parse through what we need and allow it to go to the systems it needs to be at inside of our head. We can talk about threat response with the amygdala, memory with the hippocampus. You know, all those structures are going to serve a purpose and you need to think them all through. So don't just jump to conclusions. Make sure. Good kitty. We'll play later. Think through how all of them are going to come into effect. Obviously, the cardiovascular system. You got to think about not just the heart. You've got to think about the blood, and you have to think about the vasculature. That's why we talked about things like branching and interception, and how those are going to increase our capillary number, and how that's really important to understand. In fact, I still do my own reading and trying to learn more. What was really interesting is there's some arguments about how there's limitations to muscular size, and it's actually based upon a number of different, finite realities of muscle. One being the myonuclear domain, meaning one nuclei can only maintain a certain amount of muscle fiber, like can only produce enough protein to really keep up that architecture. Think of it like if each of us is given 1,000 acres of land to farm by hand, we're only going to actually be able to farm a certain number of acres because we just can only do so much work in a given day. That 1,000 acres is not going to be fully used simply because we can't do that much work by hand with hand tools. So hence the limitation of the myonuclear domain. Then there's the idea of a limitation of vasculature and effectively circulation to the muscle. So if you don't have enough capillaries going to that individual fiber, it's not going to be able to obviously get enough nutrients delivered to it to maintain its size, along with be able to get rid of its waste byproducts appropriately so that it doesn't suffer any apoptosis because of cell signaling, because of any of those issues there. And then there's some arguments that it's limited on effectively kind of your proteomics / metabolomics, in that some folks literally don't have as many ribosomal proteins inside of their cell. So just like if we think of the nucleus as the factory building the proteins or sending the signal, the ribosomal proteins are the number of workers. So it's not just having more factories, but it's also having more workers in said factories, or technically right outside of it if you talk about cell architecture. So there's a lot of stuff going on, guys. And obviously your final is meant to be very, very applied. And so you have to think things through, and it's going to take some time. A lot of the questions are obviously not meant to be easy. Obviously it's open book, open notes. So I expect you to hit this thing out of the freaking park. If I ask a question about how does skeletal muscle, or what would be optimal skeletal muscle for an athlete, If you're just going to throw out muscle fiber types, you fail that question. We haven't even touched upon our energy systems. We haven't talked about essentially our storage of different macronutrients, so really carbohydrates and fat inside of the muscle. We haven't talked about nucleation. We haven't talked about any of those other far-reaching consequences that are going to, in fact, affect performance. Now, obviously, we haven't talked about it yet in the class, but how many of you guys have ever heard of myostatin? How many of you guys have ever heard of myostatin before? And I also have it set up so that you can do like the yes, no button. So you can just kind of hit that on the poll. Thank you, Tinks, for being a better kitty now. Yeah, that's you. So I'm guessing from the, oh, thank you, Abby. At the end of the day, oh, there we go. Now, sorry guys, it took a few moments, and Courtney and Gracie. Myostatin is a protein that naturally occurs inside of your muscles and effectively limits how big your muscles can get. So myostatin deficiencies actually allow for muscles to grow far bigger than they would have otherwise. So like Belgian blue cows are an example of an animal with a myostatin deficiency. You guys have maybe seen pictures on the internet of like a whippet that has a myostatin deficiency, and it looks like it is just massive and jacked. It looks like a pit bull with a smaller head. And that is once again coming down to gene expression based upon, you know, a number of different components that are influencing muscle size. So there's a lot that goes into it, and it's not just about muscle fiber. And remember, we still have those hybrid fibers. So those fibers that are going to be able to convert based upon training into more properties of type 1 or just completely into type 1. And we tend to lose those type 2X fibers /B. I don't really care on the nomenclature. It doesn't make a big difference. Most people would argue there's two, type 1, type 2A, and type 2X. Cool. Most of your type 2X fibers are hybridized with your 2A and with your type 1. Any type of training typically is going to transition them more towards whatever the training stimulus you're doing. So if you're 2X and you're doing a lot of resistance training, they're going to convert more to 2A. If you're doing more aerobic training, they're going to transition more to type 1. Nature of the beast, and that's completely fine because your body is trying to optimize for whatever stimulus is being applied to you. And that's getting back to our basic principles of training, which comes down to that specificity, individuality, obviously some form of progression, variation, and then the wonders of reversibility. And keeping in mind that all of those are going to play into the effects that we're going to get from our training, and how obviously one individual is going to react very differently than another. And it's just important that we keep that obviously in mind when we look at anything from the training program to the supplementation to the recovery modalities that we're going to need or prefer to use, shall we say. Any other questions that you guys have for the final that I can help with? And I'm going to go see what Norbert's freaking out about. So go ahead and throw that up in the chat or say it loud enough upon my return. My house is not that big. Norm, is everything okay out there, buddy? Yeah, you're wagging your tail. You got the market something. Yeah. There's nothing outside. Thank you for protecting us from the nothing. Bahamut, keep being the best damn pet we have. Yeah, Tori, there's still going to be the wonders of how muscles contract. Specifically, when it's going to be I believe it's a multiple choice question where it's going to be one of those you have to put it in order. So it's not going to be write out every single step. It's going to be looking at that and organizing it in order. It's open book, open note, guys. If you screw that up, I can't help you. Did see that we could leave and come back with a final, so we don't have to work on it for 7 hours straight. Once you hit start, the timer's rolling. So when you hit go, Gracie, you only have And actually, let's do this because I've got Blackboard up in the other one because one person already did the exam and that's cool. Currently, it is set so that you have 420 minutes and then it's going to auto submit it. So you figure if, man, I gave you guys way too much time. I should decrease that. Yeah, so you got 7 hours effectively, to do it. So you can log in, start on a little bit, and then take a break, come back and work on some. But you got 7 freaking hours to go through everything. So use them to your advantage. Make sure you start it at whatever time works for you. You do not have to do it all at one sitting. You are going to be able to, effectively log out and log back in, and the test will be in progress. But yeah, I can't help you guys if you're not gonna get it through. And it's open until May 6th at 3 p.m. Now that also means if you decide to start the exam at 1 p.m. on May 6th, congratulations, you only have 2 hours to do the exam because it's going to be due at that time. Anything after that is late, and I'm just going to subtract a bunch of points so that way I can maintain my own sanity. So does that answer your question, Gracie? And it's not like you have to work on it for 7 hours. Once you've done it and you've got everything correct, or at least what you think is correct to the best of your ability, call it a day. Take it easy, move on and put your time into something else. It shouldn't be that brutal. Obviously it is pretty all-encompassing and it's applied. So you have to think through how you would apply this knowledge with the understanding that you're gonna have to earn every damn point on it. Like none of it's gonna be given away. You really have to make sure that you do your best to, fully answer each of those questions because, like anything else, it's not a good choice to kind of take it easy and then underperform. And I haven't done the full tabulation of how many points the semester is out of yet. Because honestly, I've been seemingly perpetually grading things for my activity classes because it turns out they do a lot of things there. Yeah. So I think altogether the semester, once we get everything done and entered, and I haven't entered the extra credit also, so don't freak out about that. That is coming on all accords. Make sure you guys get that in. Yeah, we got the final exam. Good. Any other questions, comments, concerns, things I can help you guys review, things you guys would like to go and talk about? Oh, remember the King of the Hill, guys? Whoever gets the highest score on that, and you have unlimited attempts on it, gets an immediate extra 50 bonus points to their final grade in the class. And currently, I still have to go through and manually grade a couple of them. The leading score is a 5.6, and remember, whatever score you get on that King of the Hill is extra credit. So you're going to get that many extra credit points anyways. So it behooves you to do it. Awesome. Okay, so yeah, altogether it looks like the semester is going to be out of about 590 odd points. No, that's wrong. It should be 570 points from the things that you guys are going to have. So that number might be coming down a little bit, but that gives you an idea of what you really got to be shooting for on the final and making sure you get everything else done. Any other questions that I can help you guys with for reviewing for the final exam, of things to hopefully clarify and make sure you guys have got everything good to go. All good? Okay. Tori, glad to hear, and hope the rest of you guys are doing okay out there. Yeah, stay safe, folks. I'm gonna reply to email questions you guys have for at least the rest of the week. We won't have this on Friday since we're obviously not even clearing a full half hour, which is absolutely okay with, I think, everybody here. But that way you guys can focus on whatever you need to do for putting your energy. If you have a question about anything we covered in Exercise Phys and you'd like me to dive into it and talk about it, I'm more than happy to kind of shoot a video via Zoom or something else, and I'll put that up on YouTube so you guys can have that as a reference to look at. And hopefully that can clarify any questions you might have. But otherwise, guys, stay safe. Sorry the semester obviously had to work through and end up like this. Kind of sucks, but hey, just trying to make the best out of it as we can. And like I said, if you guys have got some concerns, let me know for the missed quiz grades, because I know a number of folks have got those. I'm going to be just probably filling them in with the adjacent grades and kind of letting everybody have that buoyed up. And if you don't like it, well, shoot me an email. We'll talk about it. And yeah, guys, stay safe. Okay. So, all right. Thank you too, Emily. By the way, I got the protein powder. I'll put it on my doorstep for you. I'll shoot you my address. So that way I don't have to worry about the rest of you guys sending me God knows what in the mail. I'm kidding. Have a great day, guys.
Sounds good. Thank you.
Anytime.